So, more or less, I have to know, well, if k is greater than 1, then it's mostly products. Just k is at equilibrium. Basically I'm just confused with the relationship between k and q.
Okay. So k is it's going to be your fixed point. So k is our equilibrium, right? We have the k, c, e, or eq for equilibrium, right? K is used concentration, k is partial pressures, right? Yeah, those two.
We use k, all of those, yeah.
Okay. So what q tells us, q functions the same as you have the products over reactants, but you start like at an initial state. It kind of tells you the change that's going to happen in the equation. Most of the time when you're doing these, you'll have a plus b goes to 2c or something like that. And you'll have a number here, but a 0 here. So it's fairly obvious which way it'll shift. Or you'd have it vice versa. The numbers and the zeros here. Q would be the case where we have numbers everywhere. Or if we just want to do a comparison, like which way is it going to move? You can do k and q without having to do an ice cube.
Okay.
So in this case, we don't know which way they'll shift. So we've got our I. We don't know which way they'll shift. So we can't get to equilibrium yet. So what Q lets us do is take, okay, we've got C over our A and B. And based on this number, whatever this number ends up being, we kind of get to learn which way they'll shift. So if Q greater than K, do you know which way it'll shift?
I did in my notes, but
Basically it'll shift towards the reactants. Similarly, if Q less than K, it'll shift towards the products. And of course, if Q equals K, then you're at equilibrium and you're not moving at all. And this is kind of the easiest way to remember it, because you just kind of look at the inequality arrow and you think, I'm shifting the opposite direction.
okay.
So the other way to think about it is typically when you have a actual number. So let's say our K is 15.
Can I shut this?
Oh yeah, go ahead. So our K is 15. So let's say we get 8.1 as our Q. Q, not 8. All right. So what we can do here is we can kind of do the same sort of comparison. We know it's products over reactants, right?
Yeah.
So right now K is sitting at 15 products to 1 reactant. Versus our Q, which is 8.1 products to 1 reactant. Now for Q to shift the correct way, we want it to shift so that it becomes the same ratio. So we need to think, do we need to increase products or do we need to increase reactants?
Since Q is less than K, you would need an increase in products.
Right. Just like that. You could just increase this up to 15 and you'd be done. Of course, chemically wise, these would both shift in tandem because that's how chemistry works. But from a mathematical perspective, you can kind of just look at it this way. It's kind of the nice thing about chemistry is you can kind of take out the chemistry aspect for just a second to look at it mathematically how it should work. So, and then you could do the same thing if this was 81 instead of 8.1. We need more reactants to make this a smaller fraction. Right.
Okay.
So that's basically what Q does, is it tells you what this change will be. If it's going to be a plus or minus over here, a plus or minus over there.
Okay.